Hello once again, so welcome to Get Another Problem Solving section with Special Maths. We have Problem Corner, February 2021. So welcome to level 3. All right, so let's look at level 3. So we have tau. It's a collection of points in the plane so that each circle in level 2, so the ones passing through those centers. So last time we had 12 circles. Okay, so for each of those circles, that it passes through at least in this our collection. What I mean one number of such to understand what it is. So if you basically draw say some circles, collection of what tab and look like, it would just be simply all the points of intersection. So this would be tab. But we want the minimum, meaning that there are some of this we could do without. So for example, we could just go with this one and this one. That would contain all the circles. So the first one contains this circle, and this circle. Then the last one contains circle. So these 2 points will contain all the circles. So we want to get this as few as possible. So generally, if you look at 12 circles intersecting, let's say at 2 points each, then 2 times 12 choose 2, which looks like a big number, but there are going to be lots of repetitions because they come from similar sources depending on the colors. So let's get all the way back to GeoGebra. So it's going on really. So in fact, you might have taken a guess from the previous video. Seen that, go check that out. So what we had before, so this area. So what we had here, if you observe well and look at the circles, so the circles we're watching now are the green circles and the purple circles. We're looking at them as a collection. So they're going to intersect at lots of points. For example, all the orange points, which are the centers of the initial circles in level 1, they all lie, they are all points of intersection of circles of different colors. The same goes with the initial points A up to H. So, for example, A, which is purple, lies on almost all the, not all, but almost all the purple points. Right? So, for example, if you just decide to go with just A through H, that definitely covers all the points. Or if you just go with 6 of those. So if you could narrow it down a bit, but it gets much better than that. Okay, so if you look at this diagram very well, there are 2 points that are kind of quite, so I say crowded. So just use a different color to highlight this. Let me say this. So look at these 2 points. So you observe that it seems all the green points, all the green circles passes through the one of it, and then all the purple passes through the other. So from this, if this were true, in fact, this gives the minimum solution. So first of all, we show we cannot get any lower. Suppose we could get lower, that means basically all 12 circles have passed through the same point. Now that is not possible. That's because if a circle is let's say look at purple circles that passes through A. So that means these circles have all passed through A, and if you observe, the other point of intersection will be some other purple point. So the only point they have in common so far will just be A, right? And the U we are talking about. Okay, so suppose the green also passes through a common point with this, then that will mean some of these points we just have to coincide, because clearly they are different. I don't have any points of view. So if you look at just particularly the ones passing through A, they pass through both A and U at the same time. So if if any other, let's say any other circle is going to pass through one of those points. So either passes through A or U, since you're pass through a common point, and that's not just possible. So 2 is the minimum. There's an honorable mention 3 points. So I don't know if you could see them. So there's one here. So that contains 3 circles. So there are actually 3 of those. Let's see if we can figure out the others. Probably we need to zoom out for a bit. Okay, maybe zoom in order. Let's zoom in. So there's one here and another one here. So let me just color this pink. So I'll color this pink. Let's just go with this one. And this one. So that's pink as well. All right. So this as the honor mentioned. Why that is true, we'll see more about these 3 points. We'll get to the bonus section. But they all contain 4 circles each, and there's no repetition among those circles. So this is indeed partitioning. So we have a full collection here. Okay, so how do we show U and V indeed what they look like? So how do we show all the purple points, all the purple circle meet at a common point? If you can show this for the purple, then by symmetry, definitely it's going to hold for the green. So we can just focus on one of these and we have what we need. Okay. All right, so to see this, we are talking about 6 circles, right? Or any any of those any two of those 6 circles will be able to like kind of determine the position of U. So that means we want to show that the remaining 4 points, the remaining 4 circles will pass through that same point that we already determined. Let's see how we could go about this. Okay. So okay, let me go back to okay, just write this properly. Okay. Okay, so let's see what we have. So I want to show that all the purple passes through U. So we have to define like what U actually is. So first for all these purple circles, they are there are 6 of them, and they kind of let me give this as their symbol. So they compare with all the purple points. So for example, we have the one pass through, so we just denote it by omega AC. So we have similar ones. So these are the purple points. Okay, so we have CE. So there are 6 of them, and all those points written at the name of the circle, they are definitely part of those circles. Okay, so you have CG, you have DG. Take if you take U to be the second point of intersection of AC and the one through AE. So why is this the second point? Well, we have A being common. So the circles are going to meet again at some other point. So that's what we're going to call U. So first of all, if we have such a setup, we're going to show that U is also going to be part of circle CE. So the circle passing through the other 2 points different from A. So we can show this. So how to go about this, right? So let's say we had A here. So this is U, and so C somewhere this so, and uh, E somewhere on this circle. Okay. Then if we draw the perpendicular bisector of AC, that will form the two centers that created this circle to begin with. Okay. And then if you also draw the perpendicular bisector of this, you get similar results. Okay, so this is what we have for now. But let me just take you back to the figure we had before, so that we could get a bit more information or move on. So basically, I want to just talk about um, the angle. So the directed angle AUC. So if you look at AUC, it's going to be the same the angle here. It's the same as the angle at each of those, in terms of directed angles, at each of those centers. So if we get back to the angles at those centers, then we can we can properly analyze what this means. So let's just quickly return back to the figure. Okay, so once again, so we have A, so we have A and C. So we have A and C here. Okay, so that gives the circle. Now, if you look at the centers on that circle, so we have the one at I. So we have the one at I here. So we have one at I, and the other center is at be at J. So that seems okay. Yeah. Okay. So we have at J up here. Okay. So this it forms a circle. You have some right angles at A and C. But this particular angle, if you recall now, this particular angle was 2 times theta, where theta is that's AJC was equal to AIC, which is 2 times A and any where X can be any of the green points. So it can be B, D, F, and H. So the point is that we can now also, since U lies on that particular circle, yeah, we get that this is also equal to AUC. So the angle AUC is just 2 times AXC, where X can be any. So that's the most important bit. So it can be any of these points. So we could use any of these to represent it, but that's not the only one that works. So we could change, we could exchange this with any of the other 4 green points, and that's still cool. Okay, so that's just what we're going to make use of to show what we want. So going back to where we are, so you see that this angle is equal to 2 times the directed angle of A. So I'll just use B, but we could change that to any alphabet we want to. Yeah. So we have this, and in a similar way, we also have AUE. The same U is this A, B, E. So once again, B is not unique. We could use D, F, or H. Okay, so with this, then what this implies that if you look at CUE, what we get is that we can write this as CUA plus AUE. So just like vector from C, we get to A first and then to E. And then this is just negative of what we had here. That's minus ABC plus 2ABE. And we can now write this as, so this negative, so we can rewrite that. So this is just CBA, and then this is ABE. And then this is just similar to how we started it. So this is just from C to A through B, and then from A back to B. So we get C to E. So in fact, this implies automatically that we have this other relationship here, which is equal to let's look at CBE. Okay, so let's get back to this circle CBE. So this definitely is going to be equal to the angle AC, so something here, E, where this could be any of the centers lying on that circle omega C. So let's go back to the diagram. Take a look. Okay, so C and E. Okay, so we need to zoom out to get E. So E is at the left bottom corner. Okay, so looking at C and E. So so we get C 2C BE, right? So we can take CBE. From what we say, that's going to be equal to just C, in this case O. So O is what we need. C OE. So this angle here. Or we could use M. So we could also use M. That gives you this angle here. All right, so we've gotten now that C, so we had that angle C UE, which we started with, is now equal to angle C, let's use M, CME, okay? Or we could use the other one as well, COE, okay? So here we have U, and we have that same angle. So that automatically means that this is cyclic. So that means U lies on the purple circle as well. So that shows the first bit we were trying to prove. Okay. All right, so let's get back to what we're doing. Next is okay, so let's get there first. We have, so now this means if we have any two, so if we have any two of these circles intersecting at a particular point, and those two circles already shared a point among the purple ones, then the third circle will follow. Unfortunately, this is not enough to generate all the other circles. That's because it's not easy to see how G comes in. So how does G come in if you started with something involving A, C, and E? So how does G come in? If you started with, let's say, AG, and EG, then the question will be, how does C come in? So this will give A and E, but how does anything involving C at all come in? If we can get one of them coming in, then automatically we now get everything, because for instance, for what we have now, if we know, if you end up getting that this circle passes through the same U, then using these two, CG will also work. EG will also work. Sorry, so EG will also work. If we use these two, there's nothing to use here, I think. If we use the first one, this one, then C being common, so we have AG also work. So we end up getting the other two. So the question is, how do we bring in the fourth one, at least for the first instance? Okay, so to do that, I'm going to take you to like a broader picture. So let's return back to our diagram. Okay. So what we have now is we want to bring in, so we have, let me write what we have. We have, we're assuming we have this, and this, all passing through U. So they intersect at U. So the question is about, let's say, AG. So how does AG come in? Okay, so what I'm going to do is I'm going to remove some, should I say, distractions. So let me remove some of these distractions. Let's focus on the main bits. Okay. Yeah. Probably keep just some of the green ones as well. Just so that we get more focused. Okay. Let me also write as well. So A, so we're interested in CG. One through CG, that should be this one, and also EG. So the one through EG, the bigger one. Okay, so that's the first one here. All right, so this is what we have. Okay. Now, what we're going to do is we're going to draw some important lines. We're going to withdraw some important lines. So, if you look at A, we have this coming AB. So just draw some important stuff. Oh, okay. Oh, sorry. Want to draw the apparent bisectors. So I see. So we already have lines initially, but just to draw, get a good sense of what's going on. Okay. So we have all this. Okay, no, not this group of lines. So this one's passed through this point. That's not what I wanted. Okay, sorry about that. That should be, let's use H to do this. Okay, so let's use H. Okay. And HG. All right. All right, good. So now if you look at these 4 lines I've drawn, so let me make them, let's say, red. So take this red. Then let's zoom out a bit. So if you look at the red, there are 4 red lines now. Okay. So I just use H as the center of all this. You could use D, B, or F. All the same. At the orange point. And there are going to be 6 of those points, which corresponds to the complete quadrilateral for this red line. Okay, so now among each of those points, so let's take a look. Okay, yeah, sorry about that. I need to make proper use of my symmetry. So I'm going to undo some of this stuff. So I'm actually going to eliminate one more circle. So I'm going to focus on all the circles passing through A. So I'm going to remove one more circle, which is CE. So just bear with me for a bit. Okay, so now all these circles pass through a common point. So I want to show that they will pass through yet another common point again, which should now be U. Okay, so on those circles, we have on those 3 circles, we have 2 centers lying on each of them. So for example, we have this here for AG. For AE, we have let's zoom out. For AE, we have this, and then for AC, here, we get IJ. Okay. Now, along these points, we could join this and we see some other straight lines coming in. So those are actually the ones I was looking for. So I remove this one now for now, and then also this one. Okay, so we have we have more circles, more straight lines. Okay, right, I've seen it. So we have one more circle, one more line among those 6 points. Yes. Yeah, so now we have a complete collateral. So there are lots of these complete collaterals stemming from those initial perpendicular bisectors we drew. So I'm just trying to highlight the right ones for just this particular setup. Okay, so if you look at this, so these 6 points, S, L, J, I, Q, and N, so they form this complete quadrilateral. And we want to get that if you look at the circle passing through A and E, so that's S, A, N, E. So if you look at that circle, you see that SN is the diameter of that circle from what we did initially, because we have right angles at A and at E. So it's like from this collateral, we're just drawing the circle with diameter SN. And then we also pick for IJ and LQ. They want to consider the points of intersection. So I'm not going to prove this, but I'm just going to state this. So basically, the gist of the matter is, in general, if you have a complete collateral, so we have these points. So in general, yeah. Okay, so if we consider them in pairs, so let's say A and B. There's 2 meeting. Consider 2 different pairs. Let's say E and F as pairs. Okay, so the idea is that if you pick midpoint of this and you draw circle diameter EF, and you do the same for AB for those pairs. You draw this circle, and you do the same for CD. And it turns out that all three circles will pass through two common points. So that's just what we're going to use. So I'm going to leave that as an exercise for you. That's just what we're going to make use of here. So the idea is that those, now looking at it from backwards, so now we start with the complete collateral. We consider the circles with those diameters. Then they're going to intersect at exactly 2 points. Now we already know one of those common points, which is A. So the other common point will have to be U, because we already had A, C, and AE, those two circles meeting at U. So this means AG also pass through that same U. And then that brings in G, and then we have a complete setup. So that's that does it for this particular session. So this means in a similar way, we just do this what we did here for. So the least one we could have is U and V. So we'll be looking more about those other 3 points that most of the circles pass through. So look at that in a bonus. So it's part of the bonus. So stay tuned, and thanks for participating in this. See you next time.